P block. See, P block is a very important chapter of class 12th because it mainly deals with the group 15 to group 18 elements, which are showing a lot of variation in the properties. What we find in the inorganic chemistry in these groups is that these groups are having non-metals, metalloids, and as well as metals in the same group. So all the variations we find in these groups are very important, and we must know those variations and also must understand and why those variations are taking place. Along with this, in this chapter we'll be doing certain specific studies about these non-metals which are there in the P block along with their certain important compounds. We have done group number 13 and 14 in class 11, so we'll be starting with group 15 in class 12th. So let us first talk about group 15th. Now, as we know, the group 15, it mainly, let us first do the introduction part. It mainly consists of nitrogen, phosphorus, arsenic, antimony, and bismuth. Now, let us see first their occurrence. Now we know nitrogen, it mainly occurs in the form of a nitrogen gas in the air, and we can obtain it by the liquefaction of air followed by fractional distillation. It also occurs in the form of sodium nitrate, or we call it Chile saltpeter, or in the form of potassium nitrate, Indian saltpeter. It is also mainly present almost in the form of proteins in all plants and animals. Phosphorus mainly exists in the form of calcium phosphate or chlorosphere or fluorosphere, and it is also present again as an important constituent of your animal membranes, and it's present in all the animal and plants membrane. Then arsenic, antimony, and bismuth, they all mainly exist in the form of their sulfide ores. Now, this is how they exist in their physical state in the nature. Now, after the occurrence, let us do their electronic configuration. The electronic configuration of general electronic configuration of this group is NP3. So the valence electrons they are having here are 5. They are in group 15, so 15 minus 10 is 5. So they are having a stable half-filled configuration. With that makes all of these elements very stable also in terms of electronic configuration. Now let us understand their atomic size. It's smaller than group 14 and increases down the group. So it's a usual thing with no specific exceptions to be studied in this case. Similar will be their ionic radius or ionic radii, no variations, smaller than group 14 and increases down the group. Then let's talk about their ionization enthalpies. Now, when we compare ionization enthalpies of group 15 with group 14, what we say is higher than group 14 because of, not because only of a smaller size, or we can write it's much higher than group 14 because of stable, half-filled configuration. And that is why when we write first ionization enthalpy of carbon in comparison with first ionization enthalpy of nitrogen, we find it's very high in case of nitrogen. Remember, this ionization enthalpy decreases down the group because the atomic size increases. Now let us do the next very important property called electronegativity. We know all of these are very electronegative. So what we can write is it's higher than group 14 because they are smaller in size with higher ionization enthalpies and higher affinities for electron, and it decreases down the group. So these are the general atomic properties which we are comparing it with the group 14 for this particular group. Now let us understand their physical properties. See, nitrogen exists as a diatomic molecule and it's a gas. Phosphorus, arsenic, antimony and bismuth, they all exist in the molecular form as P4, AS4 and SB4, and all of these are less. In fact, all of these rest of the elements are solids. So I can write it like this because that it's easier to understand for you people, like this is solid, this is solid, this is solid, this is solid. Now nitrogen and phosphorus are your non-metals. Arsenic and antimony are basically your metalloids. And bismuth is your metal. It's the only metal we have in this. And this is how what we find is that their metallic character in this group is increasing down the group. The reason is because their ionization enthalpies are decreasing because of the increase in their atomic sizes. So the metallic character is increasing. That is why bismuth is a metal in this case. What else we can discuss is their melting points. Their melting points increases up to the middle of the series till it increases till arsenic, and then we find it decreases till bismuth. Boiling point as such always depends on the atomic mass or molecular mass, so it increases always down the group. So these are their certain very specific physical properties.